Welcome back. July 21st. All we're doing today is presenting data analysis with Python projects and preparing for our subsequent Power BI sessions. And first up is Seth. Take it away.
Okay, can you see the screen?
Got it. Looks good.
Okay, so this is a little nerdy, right? But I saw a pandas, or pardon, a data set on Kaggle for D&D monsters. So like all the statistics for all the D&D monsters from 5th edition D&D. So I thought it'd be fun to poke around at that and see what I could see. So Wizards of the Coast, the company that produces D&D, doesn't publish their internal process for creating monsters, right? Like they give you some guidelines in the rules, but they don't tell you how they do it internally. So I wanted to look at this and see what I could see about that process, if I could figure anything out. So I got the data from Kaggle. I did take a graph from a site called Roll20, which I'll show you down here when we get to it. So I imported Seaboard, Pandas, Matplotlib. This right here, I was getting an error when I looked up the error from one of the things I was doing down below. It said it wasn't a big deal and that it was just some, I don't know. It said that this was the way to get rid of it, but that it didn't really affect anything that I was doing. So I just told it to go away. I also imported SciPy for, I've got a bit of code where I wrote 2 functions that'll display the R value on a scatter plot. So I am imported my CSV right here, right? And then this is just what was in the CSV when I imported it, right? So there's a bunch of information, the name, a URL, CR type, a bunch of different things here. Most of this I'm not going to need. So I do trim most of this out, honestly. So I'm going to clean through the unnecessary data. So here I just deleted the URL column, right? And then here I deleted a bunch of other columns that I don't need until I'm left with this, which is what I'm going to look at in below. So we have I'll get to what these things are when I get down to that point. But so here, since I want to compare the CR and the AC and HP, like these 2 numbers are they're ints, right? But this is an object. It's like a string because there's things in here like 1/4, right? Which it doesn't know to convert into a number. So I had to take all those out and then replace them all with like, so 1/2 is 0.5, 1/4 is 0.25, just so that it would let me compare the things like I want to. So here I'm checking to see to make sure that there aren't any more hashes, anything with hashes, so there isn't. And here I'm checking for nulls because I was getting nulls when I was trying to do some of the graphs. So I checked, there is 1 null. I used this to get rid of the null, and now there are no nulls. Here I'm changing the CR from a object to a float because I mean there's numbers for decimals, so it has to be a float. And so this is what it looks like. This is what I'm going to be working on basically, right? So I've got the name, the challenge rating, which is like how difficult the creature is supposed to be to fight, basically, right? So how it works is it's based around the level of the people in your group and the CR of the creature, right? So a CR10 creature, if you have 4 people in your group and they're all 10, then you should have a okay time of that. It shouldn't be too hard or too easy, right? Get the size of the creature, it's AC, which AC is how hard something is to hit, right? So you roll a 20-sided dice, you add some numbers to it. If it's more than that number, then you hit it. Health points is just the measure of how much health the thing has. So, that gets to 0 and you beat it, right? So down here, this is where I define those functions, which will add annotations to this graph right here, right? So it's what's adding in this R equals 0.93. So here, there's a positive correlation between the CR, so how difficult the monster is supposed to be, and the number of HP it has, right? So how much health it has. But right here, right where it's at 10 and kind of past that, you can see that like it's all sort of within a range before you get to this point. And then after that point, things start to really kind of scatter out, right? So I kind of come back to that later. But AC is distributed over a much smaller range than HP. It's like even the big stuff, even though AC can go to 25, even the really big things stop at 22, right? Because it's very bounded. Like where you want to be able to, what you need to roll and what it has to be to hit these things is pretty bounded in Dungeons and Dragons. So it just stops at 22, with the lowest being at 5. I thought it'd be interesting to do one of these hex grids, just because it would show like, okay, the majority of creatures, like the things that are colored here the most, are between, a little below 0, because we have those like 0.25 challenge rating things. So they're all kind of below 5 and between 10 and about 16 AC. Like there's not a whole lot of stuff that exists outside of that. Like most things exist within that range. Down here, so here's just where I made that pivot table, right? So I made a pivot table. So I've got the maximum, the median, and the minimum, and I wanted to see the difference between like the maximum and the minimum HP right here, just so I could have like a idea of what the range was. The median was kind of the most interesting to me because it pretty much follows it's always going up, right? It never kind of goes back down until you get up to this really crazy high stuff that's sort of weird in its own way. Talking about this difference though, I had some trouble getting this to work too, but I eventually did get it to work. But for some reason, what I got this to work, I couldn't get to work with to display it like graphically. Here I did the same thing with AC. So we have the challenge rating and then max, minimum, and median. And this is way more stable. So it's 12 and then it goes up to 13 for these, 14, 15, 16, 17, 18. It doesn't really start to get crazy and go kind of all over the place again until you get up to these that are, when you get up to creatures that high, they usually have like abilities and things like that that offset the difficulty of just basic, basic hitting or HP, right? Like they can teleport around or do different things with the environment that make them hard. It's not so much that they're hard to hit or they have a whole lot of HP. So that's where it sort of breaks down here at the back end. Here, I thought it'd be interesting to look at the correlation between CR and HP by size. So the size of creatures and then their CR and how much HP they have. So there's positive correlations here, right? Obviously, the creatures are getting stronger, but even then, the HP at some of these medium creatures doesn't go above 300, while some of these larger ones can go up to like 6 or 7, right?
Cool. Hey, Seth, while you're on that, go back up to that. I'm not familiar with the, it looks like G equals SNS.lm plot is creating a linear model plot. So I got that using that method. And then you're using of that linear model plot object that you created called G. You're now using a map underscore data frame method. What does that do? What is that?
That's the kind of function thing I designed earlier to get this.
Oh, that's your user defined function up top.
Yeah. So it's passing.
That draws the okay, cool. Yeah.
So it passes it there so that you get the R.
Very cool.
Yeah. So there's a lot less. I kind of got off track. There's a lot less, like AC is a lot less. It's more evenly distributed, I guess, or it's not as quite as all over the place, right? Because again, the highest can be it's like 22 with only 1 or 2 things getting like 25 and everything else being below that. So my interpret and report results are basically the most interesting thing we meet was the pretty standard like progression of the median here. And then, you can kind of use this going back to my previous or the the thing that started me out, it's like you can look at this and kind of get an idea of like, okay, well, I want a CR4 creature, right? Well, it probably shouldn't have more than this HP, right? Or it shouldn't have less than this HP. And you probably should think about starting it around 66 and then move it up or down depending on what you need, right? Same thing with AC, although that's a little bit easier because again, it's like a smaller scale or smaller range, I suppose. And then down here, I just wanted to look at size and the CR. So like the tiny thing here, that 18 is an outlier. Like that's only one creature. Most tiny creatures are like 4. So you can see there are like, even here, there are size limits are there CR limits to size, right? So you wouldn't make a small creature that was like CR like 25 or something like that, right? You probably want to keep it around this range if you want to stay within the limits that the game designers made. So that's pretty much what I got right there.
Comments from the group? That was some pretty spanky code. Nobody's got questions for how Seth did what he did, or? Alrighty then, Seth, I thought that was excellent. And I see what you're talking about. The pivot table kind of makes a like right there. Your AC, your aggregate functions of AC. It makes a kind of a complex header. And other than creating them and going, oh wow, that's cool. You know, you can create a pivot table in Python. I haven't played with the pivot table data frame. So I'm curious, I'm sure I'll be able to find it online. How do you get those column headers to be something that Seaborn won't like choke on, maybe, you know what I mean? Because that AC max in a more traditional 2D data frame, that should be like, and it wouldn't display well. That the way Python or the way Pandas is putting that out makes it readable to a human reading this in Jupyter Notebook. But to use that data as an input to something, those headers have to be a little bit different.
It says the column header is this, right? But like I've tried putting that in as well, and it doesn't know what to do with it either. So I don't know.
Yeah, there's got to be, because that's a 2D column header. It's like like it's making the column header as a list or something. Yeah, I'd have to look into it, but
and I was able to get this stuff to work right, but there's no like, I didn't, if I put marks around it like that, like you normally would, it doesn't know what to do with that.
Yeah, because that's the difference between a column name called max and a function call, right?
Yeah, but if it's, then where is it getting this information from, right?
Yeah, true.
It's not like I'm calling, I'm not giving it anything to call like
the max,
know,
right? Yeah.
You know, I'm just saying max and min.
Right. So, you're not giving it a series object to call the max function. God, yep. Cool. Well done.
Thank you.
Okay. All right. On my screen, Kevin's next.
Okay. Sorry, do you get that squeaking? I mean,
I'm sorry, say that again.
my background was kind of noisy, so I muted for a sec. But okay, can you see?
Yep, looks good.
Okay. So for my data analysis project, I just stuck with what was in Seaborn. And I decided to do the MPG data set because I'm not a car guy, but our infrastructure is kind of built around cars. So that, and like with a lot of attention climate change has been getting, I thought it would be interesting to look into fuel efficiency, at least in this data set. So that's what I did. I started out with looking at what data I had or what the columns were. And from looking at this, I decided to separate between what I thought was discrete and what was like categorical. So here I have DF physical and then DF origin, which was just the model year, the region, and then the name of the car. And then once I had those two data frames, I started cleaning up some data, which was really, looking at this, you can see that there's like, it's the make and model of each car. But I was thinking that if I wanted to compare between vehicles themselves, doing it through make and model would give like way too many different results. So I instead tried to take out just the make, which is what happened here. So I have the make column, and then I appended that to the original origin data frame, or I replaced the make and model column with that. So then I started doing my analysis. I did just the pair plot of the physical data frame, and you can kind of see that for the most part, having more of something, well, okay, let me rephrase. MPG is negatively correlated with displacement, horsepower, weight, which makes sense. If you have to pull more weight, that's going to take more power, which is what horsepower is. But and so that's going to reduce your fuel efficiency. But looking at this, I realized afterwards that cylinders was more categorical, because you can't have like 2.5 cylinders or 4.5 cylinders in a car. So I hued it instead. And that actually gave more interesting results, I guess, because you can see that with MPG as the Y variable, the lower number of cylinders, it tends to have higher fuel efficiency. I'll get into why I think that is later. So then I moved on to looking at the origin data frame. First, I was looking at the model year, which kind of, as you expect, over time, fuel efficiency generally increases. And then I looked at fuel efficiency based on origin, and then I tried to do it based on make. But there's a lot of info in this graph, and you can't even tell what is what. So I decided, since from this original box plot, looking at the origin, Japan had the highest or the best performing fuel efficiency in general. I just focused on that. But looking at this, you can see that there's Toyota and then Toyota, and then there's also Mazda and Mazda. So I just cleaned those two up, put them in Toyota and Mazda. These two aren't really. It says it's an error or something, but I just ignored it because it did what it was supposed to do. So here's what it is, and I don't know, it's just something nice to look at, I guess. Interesting that Mazda has the highest range, and Honda is like the tightest at the highest MPG, if that makes sense. Like, it has the best median at 75%.
Yeah, the overall fleet mile per gallon. That's a law, that each manufacturer is held to like a fleet average MPG.
Interesting.
So yeah, that's why that matters.
Yeah, and I thought it was kind of funny that Nissan only had one data point. So once I was finished with that, I thought I was thinking back to the cylinders and how that was interesting to look at. And I thought that, well, I was trying to relate the cylinders stuff to the origin. So I just made like histograms of each region's like cars and the number of cylinders they had. So that's what I did here. I started out with, I did from best to worst, I guess. So Japan, Europe, and USA. And you can kind of see like Japan is on the lower end from 3, mostly 4 and 6. Then Europe is in the middle with 4 to 6. And then the USA is the highest from 4 to 8. So this is just a summary of what I did. It's taken, or I'm pulling back up this data. And then I put together all the histograms, and it's kind of hard to tell, but this middle is Japan for 4 and 6. And I tried to make the palette a little easier to look at. But based on the data, less cylinders is associated with higher fuel efficiency, and I'm thinking that's most likely due to having a smaller engine and thus less weight. That's why we also see less horsepower but greater acceleration with lower cylinder vehicles. And since Japanese vehicles tended to have less cylinders, they tended to have the best fuel efficiency. Yeah.
Cool. Any questions for Kevin? Oh,
Sorry.
I didn't have any questions, but I think that error that he was getting was the same one that I was getting.
This one.
Yeah, what's that
Yeah,
say?
the slicing error, the slice from a data frame.
A value is trying to be set on a copy of a slice from a data frame.
Yeah, I didn't really understand what that meant, but I mean, it did what it was supposed to.
Yeah,
So I just ignored it.
Again, it's not like I'm a decade old Python expert, but there's two ways to go at the data frame column name, and then you can put another dimension over there. You can make another like data frame df underscore origin bracket name, and then you can say bracket 3, which is like the third row. Or you can use this loc and iloc function, which it's more than one way to get at it. But I go back and forth as to which one of those is actually which one of those syntax or methods is better than the other. But it's wanting you to use apparently
I see.
the method. Yeah. But I had a question. If nobody else. I couldn't tell where did you right there on that screen, you go from that really boring default blue palette to that pretty purple palette with pair plot, and it's doing a density plot instead of a histogram in the purple one. And so where in your code did that shift?
I think it was just because I defined the hue. So since I did that, it separated out the histogram to the density plots between each cylinder.
Okay. Yeah. I mean, there's so much automagic going on. It's tough to tell, but yeah, it added the and it also added the legend on the right there. So
yeah.
Well done. Nobody's got any other questions for Kevin? If not, we will move on. Next victim on my screen is Chris.
Hey, Don. Still working through mine. I actually emailed it to you this morning. I was having some trouble with my charts.
You emailed me today?
Mm-hmm. Not too long ago, not terribly too long ago.
Like after we started.
Right.
2 minutes ago.
Right.
Okay. Sorry, I've been looking at Zoom.
Yes, sir.
Okay, so you want me to skip you?
Yes, sir.
Okay. Next in my display is Edgar.
Hello.
Good morning, Edgar.
I'm still working on it, but I can show what I have so far. It's not the nicest looking, but I can show it.
I was gonna say, go ahead and display, and it'll be fine. You're among friends here.
So can you see it here?
Yep, got it.
Okay. So I found this data set called college majors inside this GitHub. And I'm using mainly this CSV. And so this here is just a description of each field. So I started by, reading the CSV and just checking what data type was in there. And I'm doing the same in all of these. I changed the objects here to categories because I was gonna use that later. And I'm pretty much previewing what's in each of these different CSVs in all these top sections. And some of them are kind of repeated. And the one that has the most useful info, in my opinion, is the one I use the most, which is this one here, recent grads. So here, I didn't have to clean that many things because this data set was used in a publication. So it's pretty clean already. The only thing was here where you see the zeros, that used to be blank. So I just replaced the blanks with zeros. And I believe this did that. So yeah. So here I begin analyzing some of the things. Didn't really have a specific thing that I was wanting to look at. I just kind of thought the data set was interesting just to see, what majors, how many people were enrolled in these majors, what was their median salary, just things like that. So here I sorted it by descending. So you could see, or no, here it's actually the highest enrollments. So psychology has the highest enrollments and followed by business administration, biology. This is the tail section. So which ones have the lowest enrollments? This should be a 0 here. Let me see if I can fix that. No. Okay.
I'm curious about the, I use Philna, Phil.
I tried that, but I was getting an
FIL.
error.
Huh. Yeah, and it may not be bulletproof.
Yeah,
but
I can try that again later.
Cool. No big deal.
Anyway, here is the highest earners based on the median, just sorted again. Petroleum engineering, mining, all engineering really. Here are the lowest ones. And here I started graphing some things. So here I was trying to find out how many men were enrolled in different categories of majors. You can see here, and I have to figure out the scale here because the names below are a little bit too big, so they overlap. Same thing here with women. And here I made a calculated field just to get the unemployment rate as a percentage. And I appended it to and I added it to the original data set. Here's the percent on the right. And I started graphing it as well. So the one that has the most unemployment is social sciences here on the right. This is the same thing, but with unemployment.
We got a lot of those when I was at the Arkansas Coding Academy.
Yeah.
We got quite a few folks that would get a liberal arts, sociology, psychology undergrad, and then because it sounded interesting, and it is interesting, but it's unemployable unless you take it all the way to at least a
Like
master's, if not a doctorate. Yeah, a lot of these things are really just a lot of these degrees are just preliminary to another degree. I'm sorry. Go ahead, bud.
So here I'm trying to count how many people are enrolled, or not people. Is this actually how many? It's not how many people. It's how many categories are, how many majors like these petroleum engineering are in the category. And I just made a pie chart just to show what the percentage is for people enrolled in what category. Looks like engineering is the most, and these two are the least. And here I was trying to compare what jobs, if a degree that if a job that doesn't require a degree is related to the earnings, to the median. But I think I have this wrong because it looks kind of odd. So I have to look at this later.
Well, is a non-college job a categorical variable?
No, no, it's
No, it's numeric. Yeah.
numeric.
It
It might be right. I'm not really sure.
definitely looks like the salaries are
Might be the
bracketed
scale.
at least the hundreds, if not the $1,000. You know
Yeah,
what I mean? The
100,000.
you've got vertical almost lines there, because the salary is not mixed in well with like 49,374. Everything's down to the hundreds. So that's making it look a little funny.
Yeah,
And somebody else, was it Seth? Who else had a comment on that chart and why it might look that way?
might be the scale. I'm not sure.
I thought somebody else had a comment.
I think
Nope.
I asked you last class about scaling up some of these things, and you sent me like 2 lines of code.
Who, me?
Yeah, I believe so. That I didn't actually need to use for mine because they all kind of turned out okay as far as size went.
Oh, okay. I took for action the how to make your plots bigger in Jupyter Notebook. I don't remember. You can limit the scale. I know there's a parameter for it, an argument. But it because it you know it defaults to auto scaling, but I don't remember that being a homework assignment for me. But I think this is the scale of this thing. You can't really, unless you eliminate the outlier data, there's no other way to represent it because you've got a tiny green dot way out there on the right at
Yeah,
0 that's stretching that scale out weird. And then you've got a purple and
it's
a
up here.
brown stretching
Mhm.
that scale out. So it could be, in real world data analysis, it could be that if you get data like that, that's just extraneous, and doesn't really reflect the heart of the matter, you delete it from the data
Yeah.
set. And
Yeah, I could do that as part of data cleaning.
yeah, so, but you're fine. Go ahead.
Okay. Oh, you go ahead.
Height and aspect is kind of what I used in my LM plots, right? Like the categories, if you had height and aspect, and then those are like inch values is what it said, I believe. Like it'll make that graph like huge. You'll have to scroll through it while it's in that window, right? You won't be able to see it all in one pane. I
Oh,
think.
gotcha. Okay.
I could probably
Those are Seaborn arguments or Matplotlib?
Those are Seaborn.
Seaborn, yeah. Seaborn's really good at prettying things up.
Okay, so here I made a regression plot, but it looks weird too, so I have to look at it later. But I think it should be the right, X and Y and all that. So yeah. And same thing here. Instead of jobs that don't require a college degree, I used jobs that do require a college degree. And same thing here. This looks kind of weird here at the bottom, but yep, that's all I have so far.
Okay. I think, I mean, all that you seem to be lacking would be some findings, at the end of that of what,
Yeah.
But no, well done. Any questions or comments from the group? Thanks for chiming in there, Seth.
Hey, no trouble. I can share my screen real quick and show you what I'm talking about with these resizing things.
Sure, thanks. So you're talking about the size of the actual graph, not the scale. Oh, sure. And then you get a scroll bar. Oh, yeah, yeah. Height and aspect. I guess height is vertical, aspect is horizontal. You're on mute, by the way, Seth. I don't know if you're talking or not. Or
So sorry, I can't believe that. I just tried to explain that whole thing and so yeah, height is, I believe it's 6 inches, right? And then aspect, I don't think it's as easy.
it's probably a ratio, aspect ratio.
Yeah, it's probably aspect ratio. So like it was at 6 and 2, like this is how I had it set up, right? But then
Cool.
if I double that to 12 and 4,
It gets big. There, yeah, notice how it renders it and then it stretched it. Like
yeah.
Jupyter Notebook had to, like the web page itself had to adjust.
Well, it once it renders it like it does, like I'm clicking on it, I'm having to double click on it to get it to pop up to this side.
Ah,
Otherwise it just stays at like tiny, right?
wow. Okay. So don't double click on it. Run it
So, yeah.
and leave it in that compressed looking weird state.
So that's what it looks like unless you select it.
And if you click on it, it lets you scroll through it. Interesting. There you go.
Yeah.
So yeah, if you needed it big in order to visually plug through the data, good tip, Seth. Thank you.
Like I can't guarantee that it'll work in what he's doing because this is a LM plot and that's I don't know if it'll work there, but maybe.
Yeah, I tried it and it wasn't. It was giving me an error, but I can probably Google it and see what the equivalent is in scatterplot.
Well, I was going to say there's some of these plots are, remember, there's 2 different levels of plot. There's an axis level and a figure level. It could be, I can't remember off the top of my head anything, let alone whether LM plot is a figure level or an axis level diagram. But that could be why it takes that height and aspect argument in LM plot, but it doesn't take it in pair plot or something else. Could be 2 different kinds of diagrams in Seaborn, 2 different levels of plot. Okay, cool. Edgar, thanks. Go ahead and turn that in, Seth, Kevin, Edgar, you guys that have gone, go ahead and turn in your file. If you haven't presented, please don't submit your file yet. Okay, you ready to go, Alyssa?
Yeah, sure.
Or should we take a 5-minute break? What do you guys? Yeah, let's take 5 because I'm going to want to talk after you and Jeanette go to make sure everybody's ready for Power BI. So let's take 5 minutes, literally, back at 11:28.
Okay, can y'all see?
Looks good.
So I got my data set from Kaggle or whatever you want to call it, and it's concerning student mental health. So it has things such as student demographics, mental health status, and cumulative GPA. So here we have what the fields are. In the data set, we have the timestamp, which after taking a look at the data, I saw that this was most likely a survey conducted through Google Forms, which automatically has a timestamp column. And then we also have gender, male or female, age, course of study, year of study, their cumulative GPA range, whether they're married, whether they have depression, anxiety, panic attacks, and whether they sought treatment for any of these issues. So with the data cleansing, you can see the data right here just as is. We have the timestamp and everything else. Everything is formulated as a question because, again, it was a survey. So I did have to clean that up. You also see that here we have some discrepancy in like casing where year one is all lowercase and then some year ones have capitals. So I had to clean that up as well. So down here, this is where I renamed the columns. I also dropped the timestamp column because I don't really think that we needed it. Fixing up some of the discrepancies with the year, and then CGPA, this specific value also had a discrepancy where there was like an invisible space right after that kept categorizing it on its own. So I had to fix that as well. And then the issue we had with cumulative GPA is that it was a range, as you can see here. Because it was a range, it was basically like an object, a string, I think. So I made the categories into pass fail and then later turn them into Boolean, which we're going to see later. So this is just to check that all the changes that I made went through properly. We see that grade changes from the ranges that we see to pass fail. And some of the initial insights, just wanted to see what the data types were. And the descriptive statistics. So we see that most of them are object except for age, which is the only float. But we see that Mary, depression, anxiety, panic attacks, and treatment at the beginning of the data set, at the beginning of this was yes or no. So I decided to change those to true or false Boolean later on. Here we see that age was the only thing that really had any numerical value to it. So here's where I changed everything to Boolean, changed married, mapped it where yes is true, no is false. Same with depression, anxiety, panic attacks, and treatment. And then this is where I also mapped pass fail to true and false with the grade field. And here I'm just checking that all of those things went through properly. So I had to do all of that before I even did my analysis. So here we have just some initial analysis of the data set in general. I wanted to see what the age distribution was like. I noticed a lot of the count was mostly in like 18 years of age, which is very young. And then I put all of the other categories into some by pie charts, some bar charts, just because a lot of them were true false. So it seemed like the best way to do that.
You didn't happen to look up what you call a distribution shaped like that, did you? That's got, I wonder if that's a particular where it's,
Oh,
it's,
no, I didn't look it up.
there's got to be a name for that, horseshoe
Yeah.
or something like that. Anyway.
Yeah, it looks like inverted.
Yeah, it's like the opposite of the normally
Yeah,
distributed data. It's
that's also what I thought.
interesting. All right, I'll hush.
Okay, so here we're just going to see what the data tells us. We see that our gender ratio, we have a large percentage which are female as opposed to male. And these are just people who answered the survey. So this might not be a very good representation of the population at whatever college this survey was given out to. Here we see the courses that these students take. Again, a lot of them take the first 4, engineering, BCS, BIT, KOE. Some of these I don't even really know. I Googled them last week, can't remember off the top of my head. But a lot of them do engineering. Again, that's also like a higher count, so it might be skewed because of that. A lot of them are in year 1, which to me made sense because the age 18 and 19, those are going to be like freshmen. And then we have whether or not they passed their courses. Majority of them passed their courses. Majority were not married, which made sense. I think most college students, I guess depending on where you take the survey, right, will not be married. Majority.
I think your age wasn't your data kind of capped at like 24 years old, 24, 25 years old.
Yeah. So
I mean,
it's gonna be like
nobody gets married that young anymore. Come on.
Yeah, exactly. And then now we're moving into whether they have mental illness or not. So majority did not have depression, also did not have anxiety. These ratios are pretty close. I would say it could be that everybody who didn't have depression also didn't have anxiety and also didn't have panic attacks, since they're so close in ratio. That's my thinking. And majority of them did not seek treatment, I guess because majority do not have mental illness, so they answered no with this question. But we do see that some people did seek treatment, and this might be a small portion of the population that actually did have some mental health problems. So I just gave my thoughts in the analysis, where we saw the majority of the responders were women, and those who responded seemed to mainly do engineering, BCS, BIT, and KOE, and biomedical science. Majority were in year 1, 2, followed by 2 and 3, and year 4 only have less than 10 students responding. Majority were passing and were not married, did not have depression, anxiety, or panic attacks, and did not seek treatment. So after this analysis, I wanted to answer a couple questions. I wanted to see what is the demographic of students who do have depression, anxiety, or panic attacks. What's their age, gender, year, marital status. I wanted to see what courses these students take, and I wanted to see whether these students who do suffer with mental health issues sought treatment, and whether they passed their courses as well. So what I did was basically set a condition where either depression, anxiety, or panic attacks were true. I kind of just grouped that under the name mental illness. You know, that's just in my head what I use to title some of these graphs. But here we're going to see the gender ratio of people who have either depression, anxiety, or panic attacks. Again, we see that 3/4 of them are women. This could also be because majority of the respondents were women too. We also see the ages. Again, 18 years of age was the highest percentage, so that reflected in our initial analysis too. And again, majority of those were in year 1. But here we can see that there is a little bit more even distribution, I think, except for year 4, which I was really surprised to see. I would imagine that a senior has a lot of anxiety, maybe some panic attacks, because they have to worry about graduating, keeping their GPA high. But I guess maybe the stress of being a freshman and moving into your dorm and not knowing anybody could be more stressful than, I guess, your senior year. And then we saw that those who are married, again, were mostly false, and we discussed why that may be earlier. And we see that this basically is reflective of the chart that we saw previously of the courses, where majority were engineering, BCS, BIT, and KOE. But again, that could be because those were the most respondents that we got. And then how many of them actually sought treatment? Not much. We saw that majority did not seek treatment, over 90%. And the good news is that they still passed. Those who had the mental health problems, majority passed their courses with at least a 2.5 or higher GPA. And I decided to do a correlation matrix here just to see if there was anything that I missed with the data, but I see that what I saw pretty much checked out. There wasn't anything that highly correlated. The only thing that I could see here was married and depression, which is not exactly what I was looking for. I was looking to see how that could affect their GPA, but any insight is helpful to me. So there might be some kind of correlation between being married and having depression. And the conclusions here, we see that 75% of those who do suffer with mental illness were female. 34.4% were 18 years of age, 39.1% are in their first year, and 75% are not married. In addition to that, most of them are studying engineering, which had the highest count of those with mental illness, which was 12 students. And of those who claim to have mental illness, only 9.4% sought treatment. And lastly, 96.9% of those students ended up passing with 2.5 and higher GPAs.
All right, well done.
Yeah,
Questions, comments from the group?
I did have something. When Edgar showed his chart, what could help your visual, Edgar, would be like maybe rotating these
I was looking at that when I saw yours. I was gonna ask you, but
Yeah, I put it right here. I used plot.bar and then plot.xticks rotation equals 90. And that helped because I had the same issue that you did. So I just wanted to put that out there.
Oh
See if
yeah,
that
yeah, that could help. Thanks.
no problem.
There you go. So that bottom line about engineering students.
Was that Don?
I've seen the bottom line about engineering students. I don't know that I would have necessarily expected that, but you know.
Yeah, I know a lot of engineering. I think most of my friends, except one, did some form of engineering. And I think it makes sense if they do suffer with any kind of at least anxiety, and panic attacks could be something because it's a very demanding course of study.
Yeah, there you go. All right. Well done. Thanks, Alyssa. If you turn that into the classroom. And wrapping things up for the day, Jeanette, ready?
Yeah, I'm ready. I'm gonna share my screen. You might get a picture of Don really quick. Oh, no, he left out. Some of my code's really long, so I'm just gonna preface with that. So if you want me to like pause and go back, I can. Otherwise, I might like scroll past quickly to get to the visual. But I decided to look at student grades, especially to see about high school students. I saw this New York study that showed that having a high GPA did not actually correlate to a successful individual. However, I saw a contradictory study that kind of showed the opposite, that getting into college and being successful, you needed to do well in high school. So I was intrigued by that and really wanted to, kind of do my own analysis and kind of get my own opinion, because I know where I stand, but let's look at the data. And so everything I found, like everyone else, was on Kaggle. And this one was really cool because it was actually used for a competition. And so there was actually a lot of insight and people actually answered a lot of questions I had, which made this one a really great one. So if anyone ever wants to mess around with the data set, I recommend this one. So I went ahead and started collecting and putting in, and there's 33 columns, and a lot of them are just very abbreviated, and to me, just a little bit confusing at times. So I decided to rename a lot of the acronyms to something that just made sense to me. And as you can see, I renamed quite a bit. But luckily there was no nulls, so I didn't have to do anything with that. And it looked like my renaming actually worked very well. However, I still felt like this was just way too much for me. It made it really hard to figure out what I wanted to start analyzing. So I went ahead and dropped a pretty good amount of these columns that I just decided not to work with. And as you can see, I still have a good amount left, but I kind of got rid of some that I maybe didn't 100% understand or just knew I wasn't going to use. So once I got that all figured out, it was time to analyze. So something I wanted to see was, I felt like this was high school, but since it is a Portuguese community, they call it secondary school. And so I just wanted to make sure I was looking in the right age group. So I did an age distribution, and I found that the majority of them are between 15 and 18, which is similar to high school here in the US. So I knew I was looking at kind of pre going to college or a trade school. Going on, I wanted to see kind of where the gender distribution lies, and I found that there are more females than males. And then I took that a step more forward, and I wanted to see the actual proportion, and I found that there is not too much of a difference, but a little bit more females than males. So I wanted to see first off if males or females perform better. And being a girl, I was obviously a little mad at this, but I saw that males through the data perform better.
So there's obviously a problem with the data.
Yeah, obviously. I should have just ended the project there. So I wanted to do a heat map. I like the colors that they gave me, but I just wanted to see maybe since there was so much data where I could kind of show my focus. This is kind of a lot, but something that really struck me was down here with the period 1, period 2, and then final grades. I saw that these were very light in color, which showed that they had some trends maybe together. So I knew that was something I really wanted to look in. So starting with final grades, I wanted to see if there was some relationship or some trend between how long someone was studying and the final grade that they get. They do it on a 1 to 4 scale, 4 being 10 plus hours, and then kind of that median 2 would be that 2 to 5 hours. So 1 being like 0 to 2 hours. So I found that it looked like grades were a little bit better the more that someone studied, but I'm not sure since there isn't a lot of distribution there. But it looks like the person that did get a perfect score of a 20 out of 20 did study 10 more hours. So I thought that was kind of cool, but however, someone did get a 19 and they didn't study near as much. So I can't say for certain that studying meant anything. I wanted to make an average column. I know that there was the final grade, but I wanted to average the 3 of them together just to see if that final grade was related to period 1 or 2, or if it was something that some individuals just do better in certain periods, which this was cool. It actually gave me the average of everything, and I did not know I was going to do that. So I thought that was really interesting that a 6 was the average grade, considering a 20 is the best. So continuing on, I wanted to see the study time between the 2 schools that the data was over, and then also the average grades. So I saw that it looks like one school studies more than the other one, and the grades kind of show a distribution, but it kind of looks like the study time does not 100% affect the grades. So I wanted to see a lot of the student data. This is kind of where I was talking about, I have a long line of code, but I decided to do box and whisker plots, and this was actually super cool. Google's awesome because I wanted to see if you can do a box and whisker, and I saw someone do something similar. So it kind of shows the median of these values. So you can see that average grade is a little bit higher if the mom is where she went to college and beyond education, as well as the father. And then I've really noticed something with commute here is that the longer it takes them to go to school, the median score was a little bit lower with more of a commute. But it just kind of helped me visualize all the information and kind of go forward with my report. Again, kind of long code, but this was kind of when I started the average. I wanted to see the distribution and compare the histograms between the 2.
That's cool though, but that's how we set up that that Anscombe data, the matrix of subplots. And that's where I was talking about the error where you couldn't do height and axis or height and aspect. Seth, it might be that you can only do height and aspect on a figure level plot, which is what this group of subplots is called, a figure level versus axis level. Could be.
Yeah.
Anyway.
And I'm happy to send you, Seth, if you're curious. I can send you any of my code.
Well, I'm going to see this and play with it because you're turning it into the classroom. But if y'all want to see this notebook, just feel free to reach out to Jeanette.
Yeah.
Cool.
And since I saw just so much trend of these, I really wanted to then create some scatter plots. So I broke them up between the schools. I found that more people go to the school on the left. And so that's kind of why I wanted to break them up, just to see if they were different in any way. But between this, I saw that if you do well in period 1, you are likely then going to also do well in period 2. again, I broke that down and I just compared then period 1 and then the final grade that they received. This one wasn't so much like straight up and down, but it did kind of still show that doing well in period 1 is not a bad thing for your final grade.
Yeah, I've seen a concept called introducing jitter when you've got it's continuous data, but not really, because it almost looks like categories. It almost looks like you're either 5 or you're 5.5 or you're 6 or you're 6.5. When a score works like that, it's not really categorical, but it looks that way on a chart. I saw a demo, I can't remember, on YouTube not too long ago, where there's a jitter equals yes or a jitter score that will randomly flux that X variable, as it almost kind of like randomly turns it into a continuous variable. Anyway, just FYI, it's called jitter.
I would have liked to mess with that because some of mine, just some of the scatter plots I would have liked to use just look so weird, kind of because of what you're talking about. So that would have been something cool to try out. And then I checked it with the final grade and then average. So the average of the grade was actually pretty similar to then the final grade I found. Again, I just wanted to see the breakdown of this graph up here then with between males and females. Again, you can see a lot of the orange and a lot of the males doing well. So I was curious, they had alcohol consumption as one of the columns. I just wanted to see if that had any effect to how well students were performing, going out and partying on the weekends. You're not studying. There's definitely more females. I mean, more males than females in this, but you can see a little bit of a downward trend line between the more alcohol consumption and the grades. I also was curious about commute. When I was looking at the heat map, I noticed that commute kind of had a relationship with grades. And so I was just curious to see if how far students are traveling, if because they're spending so much time in the car, they're maybe missing out on vital studying time, or maybe they miss part of class just because of how far they are traveling. And then I also wanted to see about age. Most people were that 15 to 18 range, but I noticed that there are some people that are 22, and I wanted to see if why they're still in school maybe is because of their grades, and it looks like it could be. And then I was curious, based off of my question for the project, was the desire for people to do higher education, which I thought was so interesting. But everyone in, I can't say everyone in Portugal, but it looks like students in Portugal actually are really excited about higher education and motivated, because even if people are older in that 22 range, a good amount of them, or 19, where they are kind of past that 18 where you graduate, still a lot of them were wanting to get a higher education. So I thought that was super cool. As well as I wanted to see if how well people are performing on school, if that made them not want to get a higher education. It looks like females might be a little more, or females might want to get higher education more, but again, there are factors and grades, but it looks like a lot of people, no matter how well they're doing in school, they still want to get that higher education. Again, I was super intrigued, and so I put in how many times they failed classes, and again, I saw that distribution of yes being the majority. So that's the end of my graphs, but I thought a lot of this was super interesting. I loved how the motivation was really shown. It looks like the students, despite maybe something that we would perceive as negative, did not really stop them. I did find that commute, study time, and family education, and maybe that drinking might affect a little bit of how well they perform in school, whether that be negative or positive. And kind of in my conclusion, studying well and trying to do well in period 1 really showed a successful student in the future. And then I'm open to any questions if anyone has any.
Anything from the group? I'm curious, did you draw bar charts? I'm not exactly sure what Seaborn is doing with those categorical charts. No, like where you got where yes and
Yeah.
no, you know what I mean? It looks like it's trying to do a scatter on a categorical.
Yeah, I was kind of messing with these. I tried to add in a bar, but it kept getting an error. So this was kind of a, maybe if I had an extra day, this would look better kind of thing.
Well, I'm just wondering, I mean, it's like Bob Ross, happy accident. What is
Mhm.
it doing? Look like right now, right on your screen, where it says, higher education desire, yes or no,
Mhm.
and then class failures. So you've got a numeric variable on your y-axis that's either 1 or 1.5 or 2, but it looks like, really, no kidding, it's either 1 or 2 or 3.
Yeah.
And then on your x-axis, you've got yes and no, but it's spreading the dots apart from each other. And I'm having a hard time. Is anybody, do you know why that's doing that? Why it's spreading those dots
No,
out?
I tried looking it up because first I was curious if I could even like compare the two of these together. And you can, but I was curious. I don't know if they just do that so you can see the data better and it's not just one big dot. So I'm not sure if they just do that for visuals
I don't know.
sake.
I'll
But it's definitely something to more look into.
Well, I love playing around with Python. So please, well done. Turn
Thank
that
you.
in and you are complete. Okay. All right, good job, guys. So everybody that went today, good example of what I was looking for. Yay, well done. All done with that one. We may do a little bit of Python as we go forward because there's some stuff I still want to cover depending on where we have gaps and time. I think we've got 3 weeks. Today is Thursday. Yes. Whew, good grief. I think we have 3 more weeks, and then we hit the project where we don't meet anymore. And one of those 6 class meetings, we're doing machine learning, cluster analysis, classification, and some regression testing, regression analysis, some more advanced stuff in Python. And I'm so happy that Dr. Ellis was able to do that during the summer semester. So that's going to be on Tuesday, the 2nd or 3rd August. But next week we're doing Power BI. So we've been talking about this forever. I'm assuming that it looks like everybody's on a PC. I don't remember seeing anybody on a Mac. It's of course it's Microsoft, so they're going to shut out the Apple crowd as much as they can. There's no real straight ahead way to download and run Power BI on a Mac. You got to do an emulator and all that. There's only a PC and version. So everybody's got Power BI desktop downloaded.
I do.
Yes.
No, sir.
Okay. You can Google it up. It's a Microsoft Store download. So it's just like downloading anything else and installing it on your PC, like installing any other application. If you're really advanced with the way you manage software installs, there's a no, I'm thinking of something else. Yeah, you go to the Microsoft Store and download it. No, you can go straight to the powerbi.com or whatever it is, Microsoft.powerbi.com, and download it. Or you can go to the Microsoft Store. Either one works, but if you download it from the Microsoft Store, it automatically updates. I'll go ahead and share my entire screen. Like here is this is going to be our final product for our workshop. But if I go and I say file about, they do a drop about every month. So you can see here, I got July 2022. If you download it from the Microsoft Store and install it, it will auto update with all the other Windows stuff. If you go straight to like Power BI at Microsoft.com, whatever, and download it that way, it won't. It kind of depends on your environment and if you have any trouble, just contact your IT folks and make sure that like everything else we've talked about for this course, you've got permission and you're not violating any rules, but we should be way past that. So yeah, go ahead and get the desktop, Power BI desktop downloaded. And that'll get you through 90% of what we're doing. It's really, it's like Excel on steroids, I think is a pretty good way of putting it. And it's the next level tool that lets you share the results, but not give people the opportunity to goof it up like Excel. If they go in and they click on the wrong thing and mess up their version of the report, you know what I mean? It's just a file. So sharing data like that file based is kind of, and there's some other weaknesses of Excel. So anyway, yeah, Power BI Desktop is the way that you design and create these reports, and then you can publish a report like this that you create to the Power BI service, which is an online thing you've got to sign up for. You've got to have a Microsoft account, and it'll ask you, hey, you know, when you go to share one of these things, it'll say you don't have a Power BI account. Do you want to start your trial? But you guys are at work, so there's going to be various levels of Power BI usage where you work. So I'm not really sure what to tell you other than if you're doing this as a private citizen, I can probably tell you what I did to activate my 60-day trial of the Power BI service. But the online share your reports, you know, Power BI service thing, I can show you, I bring that up, is really aimed at organizations. It's like you can't even really do it with a private, like I have my Gmail is my login for Microsoft for 365 for like Microsoft Word and whatnot. It doesn't even want to let me have a Power BI account as a private individual. So I had to use one of my school professor accounts that is a Microsoft 365 valid username in order to do this Power BI service. So long story short, if you can't get the Power BI service working, don't sweat it, because it's something that you would only use at work anyway. And if your mentor can't get you glued into the Power BI service at work, it's probably because you're not using it that much. So there you go. So yeah, the Power BI service it's a tab I have on Chrome, and I log into it. What is the app.powerbi.com? And I've already signed up. Yeah, here, there's my username. You can see on the right there, Donald.Walker@UCumberland's. That's my PhD gig. That's how I got into my free 60-day trial. Now, you folks that are using this, they're in the, you know, a Microsoft heavy shop, probably already have this. You know, particularly if you're using SharePoint and the other Microsoft collaborative tools at work for like an intranet, you're probably already good to go. But that's what we're doing for the next several class sessions, is learning how to use Power BI Desktop, which is downloaded and installed on your PC, to draw these cool, you know, to ingest data and then draw these cool visualizations, and then publish. There's a publish button on Power BI Desktop that puts it up to your Power BI account in the Power BI service, which is up there in the cloud on the internet. But I did want to ask for a volunteer. Are any of you like already using Power BI and you know what the Power BI service is and whatnot? I was thinking maybe Alyssa or Jeanette would say yes to that. Am I wrong?
Well, we use it, but our first exposure was through our apprenticeship. So
Okay.
we're still learning. So I'm very open to like rehearing things that maybe I've already been exposed to.
Oh, that's
Yeah,
not that. Yeah, that's not where I was going.
Oh, okay.
What I
I was
want to
like-
do. Yeah.
we're using Power BI desktop as well, so I don't think we're using like the services or anything. If that's like something that you need to pay for, we're not paying for anything currently.
No, you wouldn't pay for it. Your organization. I would, if you're into Power BI, talk to Peyton and say, hey, we've got the Power BI service, right? And I'm betting he will say yes, because you don't generally distribute the results of your work generally in a Power BI file. You can send this around just like you do an Excel file, and people can bring it up and look at it. But that's not the real magic of it. You know what I mean? The real magic of this thing is publishing into the Power BI service and then integrating all of these cool dashboards into somebody's Office 365 or SharePoint environment, kind of the intranet where it has kind of all of that documents and dashboards and calendars and all that stuff is integrated. But maybe not. Ask Peyton. So what I'm tempted to do is, since I know you guys have a Power BI mentor, Alyssa, Jeanette, I'm going to pick on you, and I'm going to share this, what you're looking at on the screen. Am I sharing my screen? I'm not, am I? Yeah, I am. Yeah.
No, you're sharing your screen.
I'm going to share this little graph, which is part of what you're going to work on. And I got lab guides. It's directly from Microsoft. It's pretty cool stuff. I'm going to share this with you guys and see if you get the memo, the message, that somebody's invited you to look at this. And it may be that I can't share my Power BI service workspace. That's what they call this. So you see these workspace over here. It may be that there's filters between organizations. You know what I mean? It may go, that's outside of Cumberland's or whatever. Affirma's, not the same organization. So it may not work, but I'm going to share this with you guys. And then we can, if you get it and can see it, we'll correspond via email. I won't belabor the class with that experiment, but that's what we're doing for the next few weeks. If you have Power BI at work, I know Christopher's mentioned it, Alyssa, Jeanette, talk to your IT folks that know about your collaborative environment, your SharePoint, your email, all that stuff, and ask them about the Power BI service. And if you can be added, if you're not already, if you can be added to the service, and there's levels of permissions, you can be added as just a member, as a content creator. And it may be, I still got some more homework to do. It may be that I can add you to mine. So I think that's what I'm going to try and do. I'm going to try and add you all y'all to my Power BI service and kind of invite you in as members. If you don't have a Power BI account, it may just go, don't know what to, can't help you. If you, or Power BI service account, If you do have a Power BI service account, it may react differently. Again, this is kind of one of those, you probably have someone who is your admin for Office 365 and these different tools and assigning user roles and responsibilities. And it's a specialty all in and of itself. But at the end of the day, don't sweat it. If you can download Power, if you got a PC, you can get through these workshops, and you can see how Power BI uses data and uses visualizations and how it interreacts. It's real interactive, really way cool. So don't sweat all of that. Just make sure you've downloaded Power BI Desktop, and we'll figure it out from there. And we will reconvene on Tuesday. Any concerns, questions?
Yeah, Donna, if you can stay on just a second for me, I got a quick question.
Okay. Anybody else want to hang back?
Hey Don, I submitted my stuff already, but I got an error when I did it the first time. So if it's corrupted or something, just let me know and I'll send it back to you again.
Huh. Okay, I'll take a look. Thanks, Seth. Anybody else want to hang back? All right, then I'll stop recording, and I'll see you everybody on Tuesday at 8:30 for Power BI workshop.
Have a good weekend.
Have a good weekend, guys. Stay cool.
You
Stay
too.
hydrated.
You all.